going to design a short column with axial load and biaxial bending. We discussed a previous lecture what is biaxial bending. So for the find the recommended use of following interaction formula. So by this formula we can understand how to design a biaxial bending column. So if here is MUX divided by MUX1 raised to alpha n plus MUY divided by MUY1 raised to alpha n is less than or equal to 1.0. So by this equation we can find out biaxial bending moment. So MUX and MUY is a moment about x and y axis due to design load. So these are the actual moment. These are the actual moment which applied on the column. And MUX1, MUY1, these are the maximum uniaxial moment capacity for an axial load PU bending about x and y axis respectively. X and y axis respectively. So these are the actual and these are theoretical. These are theoretical. Okay. Alpha n values depend on PU and PUZ. So PUZ equation is 0.45 FCK AC, 0.75 Fy AC, and PU is a shear force, or in the column sense we can call this axial force. Okay, when PU and PZ ratio is 0.2, alpha n is 1, and PU PZ ratio 0.8, alpha n is 2. So in between these two values 0.2 and 0.8, alpha n value is in between this 0.1 and 0.2. Okay. Now reinforcement percentage P may be selected for the section of axial load PU and uniaxial moment FU given by this equation. So MU is equal to 1.15 MUX square plus MUY square. Okay, MUX square and MUY square. Then after we can calculate D dash by D, PU by FCK BD and MU by FCK BD square. So this all three equation you can use to find PT, percentage of steel. Okay, and then after we can find area of steel by the PT, and then after we can find all four sides, distribute steel on all four sides and find actual P provided PFCK BD, and then after we can find MUX1 MUY1 same as we find out earlier. By this equation we can find out MUX1 and MUY1. Then after we have to determine PUZ, then after alpha n, and verify this interaction formula. So by this interaction formula we can say your column is satisfied, means your column design is safe by this formula. Okay, so let's start to design a column. Here is an example, a short concrete column of size 400 mm by 400 mm is subjected to factor axial load 1300 kilonewton. Then MUX is 190 kilonewton into meter. Design the reinforced in column assuming M25 concrete and Fe415 steel and effective cover 60 mm. 60 mm. Here is one data is missing, which is MUY. Here is given data. What data is missing is MUY. So MUY is 110 kilonewton into meter. Okay, let's start to calculate the example. First we have to find out given data. We have to write down given data. Given data in example. First given data is size of column, and size of column is 400 mm by 400 mm. So 400 mm we can find out area of gross column is 4. Let's erase it. Okay, here is a given data. Size of column is given, so we can write it B is 400 mm. Depth is 400 mm. Not a effective depth, is overall depth. Overall depth is 400 mm. And we have a effective cover. We have a effective cover. So effective cover is 60 mm, means 60 mm. So effective depth is 400 minus 60. That means effective depth is 340 mm. 340 mm. Okay, these are effective depth. Now this is the size of column. We have a more given data here. So first is a force, shear force PU. Shear force is 1300 kilonewton. Is axial load. Same as we have MUX, which is 190 kilonewton into meter, and MUY is 110 kilonewton into meter. Now we have to design a column and steel. Okay, so we are going to design a column. So let's start. Here is a page number 1. Page number 2. So first we have to select a trial. First step is selecting trial reinforcement. Selecting trial reinforcement. Okay, so trial reinforcement we have to select that we have a PU, shear force is axial force is 1300 kilonewton, and we have a MUX and MUY. So we have equation for the MU 1.15 under root MUX square plus MUY square. This is the equation. So put all the values 1.15 under root MUX is 1 MUX is 190 whole square plus 110 square. So overall moment is 252.5 kilonewton into meter. So this is the moment, this is the shear force. Okay, so we have both value here. Now we have find out d dash by capital D, which is 60 effective cover, overall depth 400. So d dash by D 0.15. Second, PU by FCKBD. Why we need to find out this? I will explain it later. Just write it down. 25 into 400 into 400. So value is 0.325 mu FCKBD square. So value mu moment is 252.5 into 10 raised to 6 divided by 25 into 400 into 400 whole square. So value is 0.158. So we have this 3 value. Okay, we have this 3 value, and one more value is Fy 415 Newton per mm square. So by this 4 value we have to find out a trial percentage of steel. Trial percentage of steel. So how can you find out? We have to go in a SP60. Okay, let's check SP60. Page number 130. Axial compression. Compression with bending. So look at here. Here is down, write down compression with bending. Means our column which has compression and also bending, and reinforcement distributed equally on two sides. Reinforcement distributed equally on two sides. Look at here. Here is a two-side reinforcement. What we are going to do? We are going to distribute it equally on 4 sides. Here is a 4-side reinforcement. But check the value is Fy. Check the value is Fy. Fy is 215 and d dash by D is 0.05. So we have a Fy is 415 and d dash by D value is 0.150. Sorry, 0.15. Here is Fy 415, but d dash by D value is 0.05. Okay, here Fy 415, d dash by D is 0.15 on 4 sides. So what we have to do? So look at this chart. Here PU by FCKBD, MU by FCKBD. So we have 2 value here. What is PU by FCK value? So PU by FCK value is 0.325, means nearer this. Here 0.325. Okay, same value for mu by bd. Mu by bd is 0.15, point 1 is here, point 2 is here, point 2 is here. So between this value 1 2 3 4 5 6 7 8 and 9. So 1.15 means in between here, in between here. So at this point both the graph meet, both the graph meet. But look at here, we have to read out these lines, these curves. Okay, this curve is P by FCK value. This curve gives P by FCK value. Look at here the values, 0.60 and 0.12. Sorry, not a 60. Is 0.40 and 0.12. 0.14 and 0.12. So our value is between nearer to 0.14, 0.14. So I will take a value is P by FCK value is 0.145. Okay, this is what I got. P by FCK is 0.145, 0.145. So FCK value we know, FCK is 25 Newton per mm square. So P is equal to 0.145 into 25. So P value is 3.625 percentage. What this value gives? This value gives a percentage of steel required for resist that much of shear force and that much of bending moment. Okay, so these are the percentage of steel. So now we can find out ASC, area of steel in a compression. What the equation? PT divided by 100 into B into D. So value is 5800 mm square. 5800 mm square. Okay. Now we decide which diameter of bar we can provide. So I am going to provide 12 mm dia bar. So 12 mm dia bar, small AST is for the 12 mm 113 mm square. 113 mm square. And look at here, I assume 12 mm diameter bar, but here is how much difference here. So I'm change it. I'm going to change a diameter of bar. I'm going to use 25 mm diameter bar, which is small AST is, small AST is 490 mm square. Small AST 490 mm square. So these are small AST 490 mm square. So right now we can find out numbers of bar by equation capital AST by small AST. So capital AST is 5800 divided by 490. So value is 5800 divided by 490. Value is 11.8 numbers. So I am going to provide it 12 numbers. So column design is completed. Column design is completed. Now let's check. Let's start checking. How we check? So we have to provided ASC. We need to find out provided ASC. We provide 12 numbers of bar at 25 mm dia. So 490. So value is 5890 mm square. These are provided ASC. Provided ASC. So by the ASC change, almost percentage of steel will be changed. So actual P is equal to 100 into 5890 provided ASC 400 into 400. So value is 3.68 percentage. 3.68 percentage. So by this 3.68 percentage, we will find out MUX1 and MUY1. Okay, so how we do it? We are going to find out MUX1 by the same formula which we done, but in the reverse matter. Same graph, P by FCK. P is 3.68, FCK 25, value is 0.147. 0.147. Same PU by FCK BD. So same values. PU is same, FCK BD all are same. So PU by FCK value is 0.325. 0.325. Okay, so by this two value and one more, one value is D dash by capital D. D dash by capital D is 0.15. So by this three value, we will find out one equation which is MU FCK BD square value. MU FCK BD square value. So let's check. Yeah. So P is here. Okay. PU FCK BD square 0.325. It is missing. Let's erase this data. Okay. Yeah, and this one also. So PU is 0.147 between here. So by this graph we can find out here. So this line gives you MU FCK BD square value. MU FCK BD square value. So MU FCK BD square value is 0.16 here. 0.16. So MUX1 is 0.16. So let's find out MUX1 is equal to 0.16 into FCK 25. FCK 25. B is 400 and D is 400 whole square. Okay, so MUX value is 256 into 10 raised to 6 Newton into mm. I am going to convert it into kilonewton into meter. So 256 kilonewton into meter. So this is the value of MUX1. This is the value of MUX1. let's go find out MUY1. So same format we follow here, same format, P by FCK. Okay, P by FCK value is 0.147, because shear force is not changing, material is not changing, 0.147. Same PU, FCK, BD, this value almost same, this value almost same, 0.325, 0.325. Second value D dash by capital D, this value also same, 0.15. So all these three values are same, all these three values are same. So intense by the graph you can find out MUY1 FCK BD square, its value is 0.16. You can see this all value are same, this all value are same. So MUY1 value is also same. So MUY1 value is 256 kilonewton into meter. Here is the value. Now we will find out PUZ. We will find out PUZ. So PUZ, we have an equation 0.45 into FCK into AC plus 0.75 into FY into ASC. Okay, so let's, okay, we have all the value, FCK have, FY have, ASC have, but AC is missing. AC is missing. So we are going to find out AC. AC means area of concrete. Area of concrete. So for the area of concrete, we will find out AC by AG minus ASC. AG means gross area of column. So gross area of column is 400 by 400 minus ASC is 5890. So the value is 400 multiplied by 400, 16440 minus 5890. So ASC value is 154,110 mm square. So this is the value of AC. So let's write down 0.45 FCK 25 AC 154,110 plus 0.75 into FY 415 into ASC is 5890. So PUZ value is 3567 into 10 raised to 3 Newton. So PUZ is 3567 kilo Newton. This is the value of PUZ. Now we will find out alpha n. We will find out alpha n. We can find out alpha n by equation PU divided by PUZ. So PU is equal to 1300, which is axial force, and PUZ is 3567. So PUZ value is 0.364. 0.364. Now we have a value, we have one chart is here. So PU by PUZ value and alpha n value. If PU by PUZ value 0.2, alpha n is 1.0, and PU by PUZ value is 0.8, alpha n is 2.0. This graph we have, what we have a value, sorry, okay, we have a value 0.364 in between these two, so let's find out this value by a mathematical step. Is 0.2 and 0.8, its difference is 0.6. If PU by PUZ difference is 0.6, then alpha n difference is 1.0, and if 0.2 and 0.364 difference, 0.2 and 0.364 difference is 0.164, then what is the difference between this? So by this formula, 1 multiplied by 0.164 divided by 0.6, value is 0.273. 0.273. Okay, so it's a difference between these two values, so we can find out alpha n. So alpha n is equal to 1 plus 0.273. 1 plus 0.273. So alpha n value is 1.273. 1.273. Now we will find out checking interaction formula. So all this value will use for the checking interaction formula. Okay, so for the interaction formula, MUX divided by MUX1 raised to alpha n plus MUY divided by MUY1 raised to alpha n is less or equal to 1. This equation given in IS code IS 456, page number 71. You can see here is the equation. Okay, so this equation is here. So by this equation we have to put all the value in this equation. So MUX value is 190, which is given in the example. MUX1, which we find out 256 raised to alpha n. Alpha n is 1.273 plus MUY 110, MUY1 256, alpha n 1.273. So by the solution of this, 0.684 plus 0.341, which value is equal to 1.025, which is more than 1, which is more than 1. okay, which is more than 1. So by this value you can see our formula is not satisfied. Iteration formula is not satisfied. So by this iteration formula you have to, if you want to do to revise the all the method and change a dimension or something else for fulfill this condition, we will do this. But here is some slight difference, just 0.25 difference, so it will be okay. So our design is safe here, okay. Our design is 12 numbers of bar, 25 dia is design is safe here. So let's draw some cross section. Here is a stirrups. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So here is a column dimension 400 mm. Here also column dimension 400 mm. It's a 12 numbers of bar at 25 mm dia, and it's a stirrups which is 8 mm dia at 300 mm center to center, and here is a cover which is 16 mm. So our design is completed here. Our column design is completed with biaxial moment.